Scientists just detected hidden heat leaking from Saturn's moon Enceladus. And this might be the discovery that changes everything. Here's what we're dealing with. Enceladus is a tiny ice ball 300 miles across, orbiting Saturn. We've known for years it has a global ocean under its frozen crust. NASA's Cassini spacecraft even caught it spraying geysers of water into space from cracks at the South Pole. But here's the problem. Water alone isn't enough. For life, you need heat. You need energy. And we weren't sure if Enceladus had enough to keep that ocean liquid long term. This new study just answered that question. Using Cassini's infrared data, researchers found something unexpected at the North Pole. It's warmer than it should be. Way warmer than sunlight can explain. That extra warmth? It's heat leaking up from the ocean below. Heat we hadn't accounted for. Now here's where it gets wild. Scientists added up all the heat escaping from both poles. 54 gigawatts total. That's enough to power 15 million homes continuously. Then they calculated how much heat Saturn's gravity should be generating inside Enceladus as it squeezes and flexes the moon with tidal forces. The answer? 50 to 55 gigawatts. The math checks out. Energy in equals energy out. This isn't a temporary hotspot. This is a stable, long-term power source that can keep the ocean from freezing for millions, maybe billions of years. Think about what that means. On Earth, our most alien ecosystems exist in total darkness at the bottom of the ocean around hydrothermal vents. Boiling water, total darkness, crushing pressure. And life is thriving there. Tube worms, eyeless shrimp, bacteria that eat chemicals instead of sunlight. Enceladus likely has similar vents on its ocean floor right now. Warm water, minerals, organic compounds. All the ingredients. The study also mapped the ice thickness. 20 to 28 kilometers. That's thick, but not impossible. Future missions could fly through those water plumes, collect samples, and literally taste what's in that ocean without ever landing. And this discovery fits perfectly with recent findings. We already knew Enceladus has water. Check. We already knew it has complex organic molecules. Check. Now we know the environment is stable with sustained energy. Check. Water, chemistry, energy, and time. That's the recipe for life. Here's the kicker. The heat at the North Pole means this isn't just a South Pole thing. The whole ocean system is active. The whole moon is in energy balance. This is global. Now let's be clear. Habitability doesn't mean we found life. We haven't detected biosignatures. What we have is an environment where life could exist, where it might have the best shot in our entire solar system outside Earth. So what happens next? We need a dedicated mission, not a flyby. Something that can sample fresh plume material, analyze the chemistry, look for amino acids, search for patterns that only life can create. With this balanced energy budget and a map of the ice, we can now design that mission. We know where to look. We know what to sample. We know it's possible. A tiny frozen moon nearly 1 billion miles from Earth with a warm ocean that won't quit. Enceladus keeps making the case that we're not alone. And we might be able to prove it in our lifetime. If this blows your mind, drop a comment. What would you want a future Enceladus mission to look for first? Microbes? Complex chemistry? Or something we haven't even thought of yet?